everyone, my name is Maria Voigt. Welcome to the tutorial, Introduction to Molecular Animation. I work as a senior outreach coordinator and web developer for the RCSB PDB at Rutgers University. RCSB is the organization that manages the PDB archive, one of the organizations. The archive started in 1971 with just 7 structures. And now we have over 237,000 structures, and all of them are freely available for you to take them and make animations with them. So what we're going to learn first, we're going to learn how to prepare a simplified storyboard, and then we're going to prepare some visual content in ChimeraX, and then we're going to save a video that you can prepare that you can use for presentation, publication, social media, and then we will also learn how to repurpose parts of the work to make a GIF animation. So this is the example animation that you can make based on the skills demonstrated in today's tutorial. And it is a narrated video by my AI friend, Rachel.
The voltage-gated sodium channels are found in neuronal membranes. In the center of the protein is the ion pore that is closed when the neuron is at rest. The ion pore is tethered to voltage-gated domains. These domains sense the increase of positive charges inside the cell. This triggers conformational changes that open the pore, allowing sodium to enter the neuron.
So what ideally you should have if you want to practice with me in the second half of this workshop, these Chimera sessions, so put these on your desktop, and the commands for workshops. The PowerPoint slides are just for you for later, and the full animation tutorial, this is the complete one-by-one command that you can use, that you can take, finish this tutorial and save these movies, and then you will have a movie just like that. When we work on any animation, we have to know why we're making it. What do we want our user to know? So in case of this little animation, of course, I made it for this tutorial, but I wanted the viewer to understand the structure-function relationship in voltage-gated ion channels. So the story goes so that we have these different conformation of the eukaryotic voltage-gated channels, voltage-gated sodium channels from PDB structures 6J, 8J, and 5X0M. And when the channel is closed, these voltage-gated domains are tilted down. And when the voltage here inside the cell increases, these domains tilt up, pull on the pore, and the ions can enter the cell. So this is the objective. This is what I wanted to communicate with my animation. And so first step that I did, I just wrote this story. So this is the story, sentence by sentence, as you heard in the animation. So once I wrote the story, and in general, the pipeline in the animation, once you have the story is always first. You go into creating the storyboard. A storyboard is a graphic representation of how your video will unfold, shot by shot. So now you see this is a storyboard that somebody created at illusciencia.com. And you see that each of these images shows what will be shown on the screen. These arrows in red shows the motions, and there is a little bit of description what happens on each of these scenes. So those storyboards are really great if you work on a team so that everybody's on the same page when it comes to visual, if you work visuals that will be shown, if you work with a client. However, if you work by yourself, I feel like there is just too much effort to create those images, and also you also have to be very good at drawing, which I'm not. So I create simplified storyboards, and I'm gonna just show you how I do it. So once I write the story, I divide it into the shots. Shots are like the single continuous takes. So in this case, it's very, very short sequences. So I divided the narration into these sort of units which will show new visual information. And we're going to be working with shot one from now on. So I'm going to explain everything based on shot one, but you basically repeat it for each of the shots. So we have the shot one, and it says the voltage-gated sodium channels are found in neuronal membranes. So now, when we have the information, we have the words, we have the story. Now we have to decide what visual elements are best to illustrate the story. So we say voltage-gated sodium channels. This is an introduction. So at this point, the visual of interest for our user would be the overall shape. So as I don't know if you remember, but I showed the model in helical, in cartoon representation. But in general, if I introduce a model, I usually use the atom or surface representation. And this is because they communicate the overall structure better. When we show cartoon representation, we actually show more information. And now we say that protein is found in neuronal membrane. So this is another visual information that is relevant for the viewer. So what a user would need to know is how is the protein set in the membrane, and where is the outside of the cell, and where is the inside of the cell. So based off the information, based off figuring out what to show visually, I write a set of instructions for myself. So I wrote start with the closed state model, begin with the cartoon view of the molecule in the membrane, and spin 180 degrees. That will showcase the 3D shape. After the rotation is done, this will be the main front view. And then indicate the membrane and label neuronal membrane because we are just drawing lines. We are not showing like lipid bilayer, so users need to, if user doesn't know what it is, they will figure it out from the label. And of course, we want to indicate the orientation of the channel in relationship to the cell. So what's inside, what's outside. So now we have the notes for our cells, what we are showing. The next step is to discern what visuals we will need to create based on this visual information. So we have to create the assets. So the asset that we need to create is the models. The views, those are the views, the saved position of the camera. This is how the scene is going to look like for the viewer. And then, of course, we have to create labels and some arrows and lines that point to these labels and parts of the 3D structures. So there is just these 4 types of assets that we need to create. And I highlighted this in color here. I usually don't do that, but to showcase what kind of assets we're going to need in the scene. You can take it even a step farther and just make notes for yourself. Scene by scene, what assets do you need to create? Since we are going to be using one Chimera session for everything, it's kind of nice to have the overview, what is used in each of the shots. So now we have, now we discerned what type of assets we have to create, and the next step is to go into Chimera to create those assets. So before we go to practice some of those commands in Chimera, I just wanted to so that we are on the same page in terms of the elements of the UI. So I'm going to refer to this as top menu. This is the toolbar. This is the viewport. This is the log. This is the command line. That's what we're going to be using. And here is the models panel. What is important in the models panel, this shows all the assets that we will be creating in the session. And these names sort of are created to sort of have human language to know what we have in these assets. But what is really essential for scripts in Chimera for using these assets is the IDs. So each of the assets, the PDB structures, the arrows, the labels, has its own unique ID. This ID, once created in the session, they will never change. And when you tell Chimera through all these commands what to do, we always refer to those IDs with the pound sign. So if you don't have any of these UI elements shown, go to Tools, General, and just choose what you need to add to your viewport, to your UI. Also, what is important, when you have the log shown, you will know that your command has run. It's going to print here in the log, and each of the commands links you to the ChimeraX documentation. So this is very practical if you want to learn more about these commands. So now we know about the UI. And there is another thing that I wanted to mention. So animations in Chimera at this point can only be created through command line interface. So you enter the commands just like here. We set up the screen, the scene. We tell it what to do. Then we tell it to record the movie. We tell the movie what to do. And then we encode the movie into our final file, which we can use. So this is if you are used to the software that sort of has the timeline and is all used through graphic user interface, this requires a little bit of adjustment, but once you learn it, it's actually really great because it's very easy to reuse those scripts, to edit very quick. So I hope you're gonna like it. But if you are interested in using the UI interface for animation, you can go to the old Chimera, which is not supported now. And on PDB 101, we have a tutorial that tells you how to work with animations using the old Chimera, the UCSF Chimera, not the ChimeraX. So on to the next slide. And one of the very important things for animation, one of the things that you need to understand before we start to do anything, you need to understand what is frames per second. This is the unit used in animations, and it's a measure of how many individual images of frames are displayed within a second. So when the movie is saved and encoded, it's a series of images that are played one after another to create the illusion of motion. So ChimeraX plays 25 images each second. So why you need to understand it? Because when you write these commands for Chimera, you're gonna sometimes want to tell Chimera how long to do certain task. So for example, in this command, we tell Chimera to morph the model with the ID number 1 into the model with the ID number 2 over 50 frames. That means that that animation, once it's saved, encoded, and played on your website or PowerPoint presentation, it's going to last 2 seconds. So that's a very important thing to understand, the frames per second. And one thing to remember from this slide, frames per default ChimeraX FPS is 25, and we're not going to be changing that. So now we know the important things, and we can go into creating the assets in ChimeraX. First up, usually you should start with creating the 3D models. So what we're gonna need for this animation is a morph. If you're practicing with me, you can now open the 00 PDB structure CSX session and also open the commands for workshop, a text file in like text edit or WordPad or something like basic text software. And in a second, we're gonna go to Chimera, but I'm just gonna explain these commands in a second. So when we create morph in Chimera, we need at least 2 structures. We can morph as many structures as we want, as long as the sequence is somewhat similar. So we have 2 PDB structures for our video, 6J, 8J, and 5X0M. So 5X0M is the closed state, 6J, 8J is the open state. So we are morphing the closed state into the open state. So in this session that I prepared for you, this PDB structure has the ID number 2, and this one has the ID number 1. So before we morph the structures, we should align them. So we use the match number 2 to number 1 command. In the session that I prepared for you, both of these structures have one chain. So now we're gonna just try out these commands in Chimera. So first up, I'm gonna copy the match command, go into the Chimera. This is my session is open, and I am going to enter this command into the command line interface and hit enter to run it. So now you see that we have these structures aligned. So one of the limitations of the morph is that it needs to align two structures, and you see that the structure 5x0m has better coverage, 3D coverage for the sequence as opposed to 6J, 8J. So once we have the morph, these parts will be lost that don't have the matching 3D structure. If you want a workaround for this, I would just go to rcsb.org and find the AlphaFold model. They have better coverage for sequences, and work with that, or work with modeling software where you can model these residues that you don't have in 3D. So now we aligned these two structures. So now we're going to go into morphing. So morph, we tell the structure, the software to morph number 2 model into the number 1 over 50 frames, which means the morph will be played for 2 seconds when the animation is ready. So I'm pasting this into the viewport, into the command line. And now Chimera is working on it. It tells me aligning something, and it's done. Now it created the morph. So now you see that in here, I got these this slider that I can slide back and forth and play the morph. We can actually go in here and hide the missing structure. And if you want an animation, a video of just the morph playing forward, you just hit this record button and it's going to record it on your desktop. So now we have the morph ready. Because we will be using command line for writing the scripts for the animation, this is a little bit impractical because you would have to start recording the movie, move this. It would record. I mean, your animation would record, but it's very impractical. So it's best when you use command line animations to use the command for the slider. So the command for the slider for the morph, to play the morph, is called coord set number, and then you put the ID of this of the model that you want to play. So this is the number 3 ID in here. So we're gonna hit here and notice it's just placed the morph from the command line. If you want to specify how to play it, so let's say we want to start on frame 1, go all the way till the end. Notice it's 51 frames, so it started with the frame that we had and added 50 like we told it in our command for morph. So we have 51 from 1 to 51. Let's say we want to play it backwards, right? So we want to play 51 to 1. So you just put the last frame, comma 1. And you can choose any frame, any range of frames. It's just going to play it and record it for you in your final animation. So now it's playing the morph backwards. So we know how to create the morph and play the morph. If you create models for your animation, you might have many different representations, right? You easily could show like atom representation, cartoon representation, show a model with certain residues highlighted, show ligands, high ligands. So now, it is very painful to create those, to sort of manage these commands one by one, to show and hide these certain elements when you record the scripts for the animation. So what I recommend to do, and this is the practice that I prefer even in other animations, to have a separate model for separate representation. So once you have your morph, right? So this is going to be our main structure. once we have our morph, we're gonna make a decision on styling. So let's say I just give it the soft light. I like this color. Now I'm gonna create a copy of this morph so that I can create other representations. So I'm gonna use the command combine. And I'm gonna type combine number 3. And notice here, it created an exact copy of my model as with the ID number 4. So I'm going to hide the missing structures too. And now I can use this model, let's say, as the cartoon representation with nothing highlighted. So this could be like my opening model, and this will be my model where I have the voltage-gated domains highlighted. So now, provided you are happy with your with whatever colors you chose, whatever light you chose, whatever background, we are going to put other features on the morph. So in the commands for workshop text file, I have these voltage gated domains highlighted. I'm using the select command. So for the select command selects the first thing. And if you chain the commands with semicolon, Chimera runs them one after another. So I added multiple commands selecting the voltage-gated domain, the residues for the voltage-gated domains. And the first command is just select and then select add, which means it adds to the first selection. So I'm just going to copy this and paste it into my command line. And now you see that it selected all the voltage-gated domains. So I'm going to go to atoms and I'm going to show them. And I'm going to go to actions, atom bonds, and I'm gonna choose sphere for the atom style. And of course you can choose some other color, light gray. So now you have all the, and now we can clear the selection, go select, clear. So now we have the models created. Notice that you have the morph with the domains highlighted, and you have another one, which is the cartoon representation that we will be using for the beginning of the animation. So those are the models. Let's see if I have anything else on the models. Yeah, that's all on the models. What you need to remember, combine command to copy the models, and the select command. This is the number of the model, the ID of the model, forward slash chain, and then the residue number. So now, at this point, we're going to be sizing the animation. So once you start creating assets such as camera views, such as labels and lines, arrows, it is very important that you work in the final aspect ratio. So a lot of you signed up for the workshop today, wanted to learn how to create those animations for PowerPoint. And when you use the widescreen format slide, this slide uses 16 by 9 as aspect ratio. That means that for each 16 numbers of width, you're gonna have 9 units of height. And there is just standard sizes that are used currently for web videos, for sharing videos. So HD, the HD is 1280 by 720. So this is the width in pixels, and this is the height in pixels. Full HD, 19 by 20, 1080. So those are the sizes that will work for the widescreen PowerPoint presentation. So to size the screen, we are using the command in Chimera window size. So if I type, if I enter that command, window size 1280 space 720, this is the HD, this is the HD size. This is gonna size my viewport to the size I requested. So anytime you get to the point that you're done with the models, you are ready to start creating additional animation elements, set the window size to the final size. Of course, you can work, so let's say you work on a small laptop, so you can work with 1280 by 720, but at the end you want to record a movie that is this size. Just be sure you're working in the aspect ratio, and later on when we learn how to script those animations, include a command that resizes the viewport so that the movie can be recorded at a higher resolution, as long as the aspect ratio is the same, which is 16 by 9 in this case. So we have the window size, and we can go into create the named views. The named views are pretty much like saved positions of the camera, and they will always be showing something that we save as a camera view. So let's say we're looking at this model like that, and I want to name this view front. So I'm going to use the command view name front. So this command saves the view, and I'll show you what happens when view name front. So nothing happened, but you see that command ran here in the logs. So let's say I move this around, and I would like to go back to the view that I liked before, the front view. So I'm just going to say view front, and then it goes back to this view. And I'm going to create another view. I'm going to call it top. And now I can always go back to the view top by typing view top. So we have now two views. If you wanna, you always have to remember what you name these views. This is your decisions. So if you sometimes, you haven't worked in a session for a while and you don't remember what views are saved, you go to view, you type view and then list. And now in the logs, you're gonna see what views were saved in this session. So just now I saved the view front and I saved the view top, but there's like an additional views saved as P1 and P2. Those are just some views that I saved before when I was working with the session. If you want to delete this view, you just type view delete. So that's how you save the views. And why are these views great for animation? Because you can switch in between one view and another view, and the transition will be animated. So let's say I have the view for the top and view from for the front, and I want to animate the structure going from front to top. And you can also specify how long that transition is supposed to last. So default Chimera number of frames, if nothing is specified here after fly, Chimera is just adding 100 by default, which means 4 seconds. I say here 50 frames, which means go from the front view to the top view over 2 seconds in the final animation. When you play these animations in the viewport, the timing might not exactly be the same. So you see, that is animated transition from one view to another. So now what is also important is that we're going to be running these commands in a sequence. So when it takes a long time for Chimera to execute a certain command, you might use the command fly with the command wait. So when you use this, Chimera is going to wait until it's done with the flying. And now you can add another command, fly, let's say top, front. And then wait. And then let's say we're going to hide something, just so we have the chain of commands. Hide pound 3. So hide model number 3. So all these commands run in a sequence, and now it's hiding. So now you see, if I didn't put this wait in here, it would just hide number 3 before it ran with the fly from front to top and fly from top to front. So this kind of forces the ChimeraX to run these commands in a sequence. Now, when we introduce things, it's kind of impractical to run it like that, boom, boom. We need some sort of break in between to like show the labels, focus on certain domains, focus on certain ligand. So what we can do, let's say we have this here, we're going to get rid. So what we have now, it's fly over 50 frames from front to top, wait, which means wait until it finishes flying. And then I'm going to add another wait command. But this time I'm going to tell it to wait 100 frames. And those frames will be recorded as animation frames. So nothing will be happening for 4 seconds. And this is the time where you can insert your labels. You can use that for narrating about certain domain or certain part of your protein. So wait and wait with frame number are a little bit different. So you see now it finished waiting, and now you see it's waiting for 100. And this is, I mean, the wait 100 didn't do anything right now, but when you record the movie, this command is gonna make the frame to stop like that for 4 seconds. So now we are done with the flying through the name views. So we know already how to create the models, and we know how to create the views for our animation. So now let's go into creating 2D labels and arrows. If you want to start with a different session, we can start session number 2. So big part of our animation, of our model animation, is the line that indicates the membrane. So what I used for that was the 2D labels arrow command. So this creates like a line only because I used the head style attribute pointer. If you use blocky or solid or pointer, this is going to be an arrow. Pointy, blocky, and solid are arrows. This is sort of like a pointed line. When you use this command, you need to write 2D labels arrow. You need to give the start point and the end point. And the start point and the end point will always, these coordinates will always be a fraction of 1, because ChimeraX viewport size is always 1 by 1. So it starts from here, goes to 0 to 1. So here is 0.5 and 0.5 here in the X. So you see that the line will start somewhere here and go up. This is actually irrelevant when you create these arrows, because you can change them later on in the viewport using right mouse button. So let us get this this arrow, this command into the into the command line. So now you see I have the line created in the middle of the screen. It's not where I want it. So what I'm going to do now, I'm going to go to toolbar, right mouse. And in here, we have this modes for the right mouse button. So what I'm going to do is choose this move label, the one that says ATP. So what happens now, my right mouse button is specialized in moving labels at this point. So I can grab it here and pull it here, and I can grab it here and pull it here. And then if I run this command one more time, I can just position the membrane just like I want. So now we have the membrane, but I changed my mind and I don't want it to be red. Let's say I would like it to be white. So I'm going to overwrite the attribute. So if you want to overwrite 1, notice that in here, our lines created a new asset with the ID number 5. And each of those arrows has its own ID with the after the dot, so 51, 52. So this is the ID that you're going to be referring to when you call these assets. So let's say I would like the one on the top, 5.1, to be blue. So I'm going to write color blue. And now let's say I want actually all of them to be green. I can edit them, type all instead of ID and change it to green. And of course, here you can use the hex colors. You can just put the pound FFF, for example, for white, if you don't want to use just the names of the hues. So this is how we create the lines and arrows. Now, so we edited, so weight, so those are mainly attributes. Those are the main attributes for the lines. We have to give start and end, and we have to give color. We can change color. Color is an attribute. It's not mandatory when you create it. You can add it later. Weight, which is, I don't know, you can make it as fat or as thin as you want. And head style, which is pointer. So, and then those are the styles for the head style, the attributes you can use. So now we have the membrane. Now we would like to label it. We want to say neuronal membrane. So that command for this is 2D labels. And then we have these attributes that we add after 2D labels. So for arrows, we say 2D labels arrow and then add the attributes. For 2D labels, we only say 2D labels. And the attributes that we can add here is the color, background color, margin, outside, size, position X, position Y, font, bold, italic, visibility, and so on and so forth. So we're going to create like a very basic label using this command. And in the same way, you can edit these labels. Just call them by attribute or call all of them. Oh, this is actually... so when you enter the text, be sure that those are not the curly quotes. That's one thing. If it's one word, you don't need these apostrophes around this. If it's multiple words, you will need them. So now we have the neuronal membrane, and we can grab it with the left mouse button and position it wherever we want it. And unfortunately, we move our molecule, but that's not a big deal because we can just say view front, and it's just gonna come back where we want it to be. So now you see that if you save these views, you cannot mess up much. You can always go back to stuff that you saved, and that streamlines your work by a lot. So notice also we have the 2D arrows as one ID, number 5, and 2D labels as another ID. And also in the same way as 2D arrows, the 2D labels will each have its own ID after the top number here. So 1, 2, 3, 4, 5, 6.1, 6.7, and so on and so forth. So now we know how to create all the assets. We created the labels, the models, the lines and arrows, the labels and the views. So what happens now? So now what I like to do is put these IDs into my notes because you cannot rename the arrows. Arrow 1, arrow 2, it's like, what's that? Like, I don't know which one is what. So it's good to put these arrows into your notes. So when you write these animation script, you can just go back to these IDs and put them into your scripts. Because we are working in only one session, we're going to have one camera session for our whole movie, and we have multiple shots. What I recommend is to set up something like a scene, like a shot setup or reset. So this will set the scene to whatever we want the first frame to be, and then after that, we're going to record the movie. So as you see here, I set up the scene to window size 1280 by 720. This is my recording size. And it's always good to have it in the scene reset because you can accidentally like move the corner of your UI and it's just gonna resize the viewport. So it's always good to have it in the reset. Now I say hide 5 to 6. So I tell it hide the arrows and hide the labels. And now show 5.1 to 5.4. That means show. So let me just open the session uh, for labels because I have all the elements created. So now in here I have these arrows, I have many of them, and I have these labels. So now 1, 2, 3, 4 are the membrane lines. So I'm going to be showing them for the opening of this scene and then show labels 6.1 to 6.3, which is outside, inside neuronal membrane, and view the back. I saved the view as back because that's what I'm starting with. And then the scene is going to, once I play the animation, record the animation, the molecule is going to rotate to front view. So I'm going to just take these commands and paste it into the command line. And now the first frame is set up for my animation. And notice, I don't need to create separate frames for separate sessions, for separate scenes, for separate views. You can keep everything in one session, clean and neat, and just use those scene resets to before you start recording the movie, so that you always can go back to the scene that you want to be the first scene. So now when you set the scene, you can start writing your scripts for the recording the movie. So you need to know how long you need, like how long the animation should be. So let's say for this narration, I need about 6 seconds of visual material, which translates into about 150 frames. So let's ignore this movie record and movie encode commands for a second. Let's look at these two commands, fly 125 back front. So I tell it to go from the back view to the front view over 125 seconds, which will be animated, and then wait to finish that command, and then stop for 25 seconds so that nothing happens, so that the users can have the time to read the label. And that gives us 125 plus 25, 150 plus give or take 2, because I don't remember whether it always records the first frame for each of the commands. So we're going to have about 151 frames in this video, which is about what we need. So now before we record that, before we can put it into Chimera, let's just spend a little bit of time with the movie record and movie encode commands, and we will just discuss it quickly. So movie record sort of records the raw footage. You put the movie record command and nothing starts happening. And then you put subsequent commands. So like here, I'll put the movie record. So nothing happens, right? But if I go into the log, you see that I ran this command. This command has run. So it means it's recording the scenes. So I give it some sort of command to record. So fly over 50 frames from back to front. So now it's just recorded this command. And if I go to movie status, like here, it tells me how many frames are recorded. So it says that it recorded 52 frames, so 50 frames for the transition and first and last frame. And it saved them to directory, var, folders, somewhere on my computer. And the estimate length of the movie is 2.1 seconds. So now, if I keep adding commands after the movie record, it's going to record everything. Let's say I say wait 50. It's going to record another 50 frames. And if I go back to movie status, it's telling me, you see, it was 52. Now it's 102 frames. So If I want to take a break and do other things, I can just say movie stop. That will stop recording the frames. You still have the frames saved in that folder, but you're not going to lose them. If you want to resume, you just type in movie record. If you hate what's recorded, you just made a mess, you just go movie reset, and I just do that. And nothing happened, but you just saw that it ran the command. But if we go to movie status, it tells you that no movie is being recorded. So it erased all these frames from this folder. There's nothing. So you have to start fresh. So now you know how to record the movie, but then we have to encode the movie. What does it mean to encode the movie? Encoding a movie means converting the raw video footage that is saved here in this folder into digital format suitable for storage, transmission, and playback. So if we show movie format command, here, it shows you what formats are available in ChimeraX. I would recommend that. Use MP4 if you want to produce something for web, something small, something compatible. Use MOV if you don't mind a bigger file, but you want better quality. So now we know what is encoding a movie. So now let's just take all these commands and run them. So let's just check, make sure that we are not recording anything. So first, we also do movie status, no movie being recorded. So we can just record something, and this is going to be saved on the desktop. So we have the first movie. It's recorded, and you can play it. So this is exactly what we told Chimera to do. It's just recorded it. And notice it is a little bit different to work with videos that way, but look how easy it is to edit anything, and you just paste them all at once, and these movies are produced right away. Why am I actually recording scene by scene? Because I find that shorter command sequences and smaller files are easier to manage. And if you like, for example, record for your PowerPoint presentation, you can just take each movie and put it on a separate slide. Now, if you want to use these movies like as one single movie, add narration, I recommend to use resources like Adobe Express. And in Adobe Express, you can just, you don't have to do any trials, anything. There is enough free resources to use the free version. I'm logged in with my Google account. I go here and let's say I want to merge a movie. So or maybe combine. So there's like ways to combine. Combine videos. So now we have here this quick actions is called merge videos. So browse. I have all my videos in for this session saved. I'm just gonna add them one by one and throw them into the and now you see it created, it's put the movies in a sequence on a timeline. You can download it, or you can even open in editor and add effects, labels, and whatever you can think of. Also, we don't have that much time. Let's just go back to the end of slide. Because everything is in one frame, you can just use different scripts to create different movies. So this is like a simple script to create a GIF animation. So I size this window size 400 to 200 pixels because GIF animations should be small, not more than 400 pixels or even smaller. And I set up the scene reset, and I'm playing the coordinate set which means I'm playing the morph forwards, 1 to 51. Then I just give it a half a second break, play it backwards, and encode. And this is actually all the materials that I have. And I would like to thank the PDB members and our funders. And also, if you have any questions regarding this session, just direct them to info@rcsb.org, and it is gonna get to me and I will respond to it.